Hello everyone, I am Aditya Chaudhary, currently pursuing my VTech in Savita Engineering College, and my project is Deepfake detection using vision transformers and contrast learning. VIT represents vision transformers. So our agenda today is to discuss about introduction, statement of the problem, scope of the project, methodology, and outputs as well as results. So, deepfake technology leverages artificial intelligence, especially deep learning, to manipulate or synthesize media content, often resulting in hyper-realistic but fabricated videos and images. While this technology has some creative applications, it poses significant risks, including misinformation, identity theft, and undermining trust in media. This project addresses these challenges by developing an advanced detection model using vision transformers and contrastive learning to identify the manipulated content with high accuracy. So our problem statement is as defined. With the rise of generative adversarial network, also known as GANs, creating hyper-realistic deepfakes has become easier, making detections harder. Traditional methods often fail to identify these subtle manipulations effectively. Our challenge was to design an AI model capable of detecting these sophisticated deepfakes that bypass conventional techniques. Our scope of the project is as follows. The project focuses on leveraging vision transformers and contrastive learning for deepfake detection. Its primary audience includes cybersecurity professionals, media organizations, and social media platforms. Key deliverables are trained detection model, documented methodologies, and a user-friendly web app. However, real-time monitoring and purely audio-based deepfake detection files outside this scope. The datasets includes diverse videos from platforms like YouTube and Twitter with a focus on both high and low resolution content. Limitations include performance variations with video quality and novel deepfake techniques. Our methodology is as follows. So the first approach to this project completion is we have to collect the data. So we are using APIs. We collect diverse video data sets which are pre-processed for analysis. Also, we are using labeled videos as real or fake data to train the model effectively. Model development. Vision transformers were used for global feature extraction, while contrastive learning ensures that model could distinguish between real and fake content with robust feature representation. So we are using a Django web application to create a user-friendly interface for video uploads, enabling users to receive quick and accurate results. This model was integrated into the app, followed by extensive testing and reliability and accuracy. Key techniques include vision transformers. These utilize a self-attention mechanisms uh, to capture long-range dependencies in images. They process images as patches, allowing for detailed feature extraction across the entire image. Contrastive learning. This method forms positive and negative pairs of data and trains the model to maximize differences between them. It incorporates augmentation techniques like rotations and flips for robust feature learning. So our architectural diagram flow is as follows. The system architecture includes data inputs via APIs, pre-processing model training, and web application integration. Use case diagrams includes illustrates the interactive flow of the web app, while sequence diagram demonstrates the detection process from video upload to result generation. Sequence diagram is as follows. So the algorithms we used in this model or in this project is vision transformers. Patches are enabled and processed using positional encodings. In self-attention layers, capture relationship between patches for classifications through vision transformer algorithms. In contrastive learning algorithms, pairs of similar and dissimilar data are formed. Augmentations ensure the model is invariant to transformation, as well as loss functions ensure effective separation in the future space. So the hardware or and software are as follows. In the case of software, we are using Python, PyTorch, and TensorFlow along with OpenCV, NumPy, and Django as for a web server, web-based application. As for hardware, we are using NVIDIA RTX series, which is high-performance GPU with sufficient RAM of 16 GB and more. The implementation is as follows. We implement the system using Python, leveraging libraries like TensorFlow, PyTorch, and OpenCV. Django was used for backend development, and the application was hosted on platforms like AWS with containerization via Docker for environment consistency. A REST API was integrated to handle video uploads and model interface. The results will be the code segments are placed. In contrast to learning, we are going to define whether the image is a bad image or a good image based on it is a fake image or a real image. Testing model code is as follows. We are going to input the video as a format in which, and we are getting the outputs as whether it is a real or fake, and we are going to give a label as predicted label for the image. This is the output which we will be getting. It is a deepfake application where we are using a Django web server to create a web interface. And we are getting an accuracy of 93.5% with a precision of 89.3%. Recall score also we are getting as 92.8%. These matrices highlight the system's ability to detect deepfake effectively and diagnose them faster than traditional methods. Outputs demonstrated the model's capacity to differentiate between real and fake videos with high accuracy. These are the test cases which we used. We have uploaded a Word file in the Steam video instead of video, and only video files are error is the expected results, and we are getting the actual results as the cause. Hence, we can say that and I am going to conclude this by this project was successfully demonstrated to the capability of vision transformers and contrastive learning in deepfake detection. The model is practical for deployment across platforms, offering tools for cybersecurity and media integrity. Continuous improvements in dataset diversity and real-time capabilities can further enhance its robustness. Our future work includes expanding datasets to include emerging deepfake techniques, improving robustness against novel fake generation methods, developing real-time detection capabilities for social media applications. This concludes my presentation. I am happy to address any questions.